and welcome to part 6 of this Talos Enablement series. This time we're going to be talking about WebSphere Liberty and containers. So we're going to have an overview of what Liberty is, what WebSphere Liberty is, um, what a container is, and why you might go about trying to put Liberty on a Docker container. We're going to see how you connect to Docker in Talos, and then look at Docker images and Docker processes, and the process of build and the process of instantiation. And then we're going to look at variable sets within Talos that are used when you build out and create instances of Docker containers. Okay, so WebSphere Liberty is an answer to a question that was raised with WebSphere. So in the beginning, there was WebSphere. It was a massively scalable Java EE compliant application server. It was very secure, it was fast, it was robust. But as lighter weight Java runtimes became more popular, things like Tomcat, um, customers wanted something lighter weight, composable, flexible, dynamic, and something that was ready for cloud environments. So WebSphere Liberty is a Java Enterprise Edition web profile that's an application server in a 54 megabyte download. It's really small. It starts in less than 3 seconds, and it's got a memory footprint of less than 60 megabytes. It's very small, very fast, very flexible. It's got a very small kernel, and you can add in optional features. So uh, you can you can compose that server to only contain the parts of the enterprise Java stack that you're actually going to use. There are several product editions. There is a core edition, which contains the Java EE6 web profile and some other core features. There are base Express and Developers editions, which add some full profile features to that, and a Network Deployment edition, which adds centralized management and clustering to that. And ZOS has other features that are exploited by the ZOS edition, but they're all nested, so they all contain that Liberty Core edition. You can download it simply from wasdev.net, and you can install and configure a server in 1 minute, according to this YouTube video. The configuration is all file-based. You can keep all that configuration as a single file, or you can call out to multiple files, but all of the configuration is held in XML files. You don't need to specify defaults, so your config is quite simple. There are good default values for things that you don't specify explicitly. And it's a BYOJ product, bring your own Java. You can use any J2SE compatible JVM, and it, yeah, and it will use that under the covers rather than specifying a particular Java version. It's dynamic, so you can just drop in applications and it will update those applications, and it will continuously monitor that directory for any changes. Uh, Etc. It has a lot of other features. So what's a container? So a container is a virtualization technology. It allows you to run multiple images of machines within a single host or group of hosts. You could think of it akin to uh, a virtual machine. Um, it's best used for microservices, so small, immutable, usually stateless applications um, are handled really well on containers because of the way that it scales, and it just overlays, container on container on container, Uh, those small stateless applications are best for that. Now, the comparison with virtual machines is not quite right. It's not that helpful. So there's a comparison here with a house. So think of a virtual machine as a house. Every house has to be a minimum size, really, to be called a house. It has to have a separate kitchen and living room. It's got to have a separate bedroom. Um, it's got to have heating and plumbing and electricity, and all of those utilities need to be available for the house to be called a house, really. Um, Everything's self-contained. Now, alternatively, a container is more like an individual apartment. Now, you can have very, very small apartments. You can have, a studio with a shared bathroom. It's literally just a sink next to a bed, and that's your apartment. Or you can get 4 or 5 bedroom penthouses that uh, you know uh, that are very big. But all of those apartments share the resources of the building. So there's only one set of plumbing, one set of electricity that comes into the apartment building, which in this instance would be the container host. So all of those, all the networking and the sort of file system management, that's all handled by the container host. And the container can then be made much smaller, only containing those parts of the operating system that you're really concerned with, that are actually going to run the application. So containers they use shared resources, they're lightweight, they instantiate fast, best used for microservices. Alternatively, VMs have isolated resources. They contain a full OS and a full application stack. They take several minutes to boot, um, and they're better for monolithic architectures. So why would you put Liberty on Docker? So there's several reasons. If your runtime is small, as a Liberty container can be, down to 50 or 60 megabyte runtime, um, if you can instantiate more smaller runtimes, you can make better use of your host resources. So you're not taking up an entire virtual machine running something that is actually relatively small. Um, you can create, deploy, and manage images much faster, and you can scale much faster. The idea of creating a Docker swarm or managing with something like Kubernetes allows you to create multiple containers that spread that workload, and it can be hundreds, thousands of containers that are all sat there processing information in parallel, rather than rather than one big machine trying to consume everything. And there is a level of built-in automation in doing that, because you're not worried about the networking or the file I/O. Um, there is creating another instance of a container and adding it into a swarm is a matter of a second's work. So it's best used for microservices, which should be the way really that we're tending toward in terms of a technology direction. Microservices reduce complexity in applications, they make deployments faster, it's easier to roll back and to test. It's easier to roll out. You can do kind of staged rollouts and then roll back if something isn't right. It makes automation easier, and it makes migration easier. So within Talos, there is a prerequisite to connecting to Docker, and that is to have Docker and Docker client. They should be running, and the TCP API port should be open, which is by default 2373. So within the Talos UI, you go into administration and you see the containers integration and Docker options, and then you can populate that information there, the Docker host name, the port that it's running on, and then the URL for the Docker container, sorry, the Talos URL from the Docker container. So let's look at what an image is versus what a process is within Docker. So a Docker image, let's take a programming metaphor, is that images are classes and processes are instances of that class. So uh, the images are the base level, the operating system, the parts of the operating system that you need, and the base products installed that will run your application. And they are saved as an image. It's like a template, effectively. Um, and when you instantiate a process based on that image, it takes like a snapshot of it and runs it. So images don't run, processes run. Processes are the actual runtimes that run your application. Images are simply the template from which the processes are generated. So there's a couple of Docker commands here that exist within Docker. So you can run Docker images, and uh, that will list all the images that are available on your system, and Docker PS, which is running the instantiated processes. So in order to create a container image in Talos, you simply go into the Containers tab, and there's a button there to create a container image. It needs an image name, it needs a version, and a middleware type. Now, if you choose Liberty, for example, um, then you have to choose a base image on which to base the container. So this, for example, we're choosing CentOS latest here. Now this will be pulled from Docker Hub, and this is just the baseline containerized version of this operating system. And then you simply build the topology as you would with any other middleware. You start stacking up those elements of the topology and filling in the details on the right-hand side. So let's look at image build versus process instantiation. So build activities occur when the Docker image is being created. So this is the master. You use this to create the template from which all new processes are created from. Um, so Talos splits this out into two separate sections when you're building a container here. So we've got build activities and instantiation activities. So these build activities will occur when we're creating the Docker image. So in this instance, we are installing Installation Manager, we're installing WebSphere Liberty, we're applying a fix pack, and we're creating a server. And that's all according to uh, the topology that we've just created. Now, separately to that, we have instantiation activities. These activities occur when an image is being created into a new process. So several processes can be created from the same base image, in fact are. So if you're scaling to 1,000 instances of your application, then all of those processes will be spawned from the same image. So when new processes are started, they'll have a template applied to them, say, and the start server command will be issued. And that's what these two instantiation activities will do. So once all of that's been defined, and we've worked out what our build activities are and what our instantiation activities are, we can click Save and Build Image, and we will go to the image build. Now the build process will do a couple of things. It will download the publicly available Docker image for CentOS or Ubuntu, whichever you've chosen as your base OS. It'll connect via SSH and copy the Talos runtime over to that target machine that you're building the image on. It'll copy over any media required. It will execute the Installation Manager installation. It will use Installation Manager to install Liberty and apply a fix pack. And it will create whatever servers have been specified within the topology that you've created. Now, containers can have variable sets. So when you apply a template, and this is going to go over several environments. You might have a dev environment, a test environment, a prod environment. These different environments are going to have different values. So this is the equivalent here within containers is variable sets. They are collections of variables for specific environments. So for example, here we're creating a dev variable set and a test variable set. And that will allow us to look at that template and set different values for each environment. Now, these variable sets are stored inside the image. So when processes are launched, they can be launched with a variable set which will give those, which will, upon instantiation, upon creating a process from the template, from the image, um, it will use those variable sets to apply that configuration and to start up that application. So if you're executing a dev environment, if you're instantiating a dev environment, you start it up with the dev variable sets, and if you're instantiating a test environment, you start it up with the test variable sets.